It's Ollie Epsimer here again in my lab. It's now middle of February, and I've been spending quite a few long Scottish nights fiddling around here in my lab, working on some new projects. My latest one I'm going to talk you through now is the Arduino powered autopilot for my boat. It's still in development. A lot of the basic functionality is already there, and I'll go through that. And also going to talk to you about some of the future functionality I'm hoping to build in, including linking it to my Raspberry Pi nav computer that you've seen in my previous videos. In parallel to this project, I'm also starting to upgrade the nav computer to include a wind speed and direction sensor in it, which means that it will be able to give me my true wind speed and velocity. And also, hopefully, I'll be able to link it to this autopilot in such a way that it can act to hold the boat on a heading close to the wind. Let's take a look at what we've got. Okay, so the first thing I'm going to do is show you the general sort of layout here. What we have here is the mechanics of it, which is my old Navico autopilot. This was built in 1991. You can tell how old it is because it has made in England stamped on the back, and you don't see that very often anymore. Now, it was a very solid piece of equipment, really strongly built, but unfortunately the Motorola brains of it, based on an old Motorola chip, actually a 16-bit unit, packed up sort of the middle of last year. I'd been meaning to look into fixing it, took it apart, couldn't really see any obvious damage, decided it was basically beyond repair. A new one was about £500, and I thought, well, rather than do that, since the mechanics are well, and I have aspirations of linking it to my existing nav computer, let's go down that route. What I've got here is, as you've seen before, the Raspberry Pi unit. That's not actually on at the moment, I'm just in the process of upgrading it, so we put that to one side, and don't worry about that. This here is the main control unit for the autopilot. Now, as you can see, it is a bit bigger, to say the least, than what the old one was. All the control circuitry in the production built version was very neatly encapsulated in here underneath the RAMs. Now, I haven't been able to do that, and I'll go into a little bit as to why that was. And I'm running this at the moment, obviously on a boat it'll run off 12 volts, but I'm currently running it off a little power supply down here. What we have is the 12 volts going in to the control unit here. We then have this rather thicker wire going into the tillerpilot. The only reason that wire is thick is because it's quite a heavy 7-core trailer wire. It doesn't really need to be that heavy. I'm using 4 cores, the others are just spares. I've also got it connected by this USB port here to my laptop for the purposes of programming. Now, this is a bolt-in type connector, so when that USB port is removed, you screw this cap on and it makes it an IP rated connection. This whole unit is watertight. There's still some work to do on it to tidy it up a bit, but I have no issue with the fact that it should work. And the final part of the puzzle is this small remote control unit here. This is a Chinese import unit, 6-channel. When you press a button on this, it activates one of 6 relays in here. And those 6 relays are mapped directly to the 6 buttons that we have on top of the control board here. So you'll notice there's a little number, 1, 2, 3, 4, 5 and 6, and they're roughly the same layout as the controller, up, down, left, right, so on. So when you press one of these buttons, it's exactly the same as pressing one of these buttons. The range on this unit is long. I can certainly operate this autopilot from anywhere in my house through closed walls using this. Now, this isn't waterproof, but I wasn't exactly planning on using it in a sort of soaking wet environment. What I'll most likely do is put it in a high-tech sandwich bag and run with that. Okay, so The control system that I've used in the control box here is all based on an Arduino. So what we have in here is we have just a standard Arduino unit, nothing fancy about it at all. We have an I2C tilt compensated compass unit. There is a relay board as well for the Arduino, and there's also the relay board and radio receiver unit for this. Originally there was also a variable speed motor driver in here. However, on subsequent versions, for reasons I'll go into, that variable speed motor driver is now installed in the actual RAM itself, and that's why I need these 4-core cable to go there, 2 for 12 volts and neutral, and 2 to operate the motor driver straight off the Arduino. So to show you how the whole system works, here we've got the code here. This code is all available on the Dropbox link in the description. Bear in mind that at the moment it's still work in progress, so you know, don't judge me too harshly by it. This code is a PID based code, so essentially all I'm doing is measuring the error, and the output of the motor is then proportional to the magnitude of the error. It's also proportional to the integral of the error, so that means that the longer it's been in error, the greater the output is, and it's also proportional to the slope, the rate of change of the error. In other words, if you give the boat a rapid kick to, say, 5 degrees off course, you'll get a bigger output than if you gave the boat a slow kick to 5 degrees output, of course. It's all fairly standard stuff. I did have to make some changes to the standard PID algorithm for this particular application. So the integral term in almost any PID algorithm you'll find, the integral term is constantly integrating. In this version here, I've done it so it resets every time it crosses a 0 point, which I've found to be more suitable. So if we just go to upload sketch, that will compile it and send it down here. If we then watch what happens once it's uploaded, it's doing it now, radioactivity, autopilot control, Ollie Epsom, and then we're into the message screen. So, the message here is FAB, it's just from Thunderbirds, means everything's okay. We're running program 0, which means that it's inactive. Our course and our heading are the same. If I rotate this unit, you can see the course changing. You can also see the heading changing with it. You'll see MOT is 0%, error is 0%, and the reason for that is, at the moment, because we're in program 0, the course to steer is the same as the heading. We've got our current draw and our voltage. Now, I'm not 100% sure that we're drawing that current. I really need to recalibrate the circuits that I've built, but it gives you an indication. We've got 2 modes of control, as I said. First thing we can do is manually drive it using this. And we can see the current goes up and the voltage goes down whenever we manually move it. I can do the same using my fingers. And we see they're altering starboard, altering port, altering starboard. Okay, now the way I've programmed these buttons is if you press them once quickly, it has one function. If you hold it down for a slightly longer amount of time, it has a second function. So in order to manually move it, you have to hold them down for a certain amount of time. And the idea here is quite simple, that if I was coming alongside, say, on my own, I could stand on the side of the boat and just steer the boat manually using this remote control unit. Okay, so we've talked about the manual modes. We'll now put it into automatic mode. We can see here, set, cancel or resume. So the way it works is you assume the boat's going in the direction you want, in this case 238. Okay, settled on course, press button 3. Autopilot active light comes on. Program changes to program 1, course to steer 238, heading 238, 239. You can see the error there. Now, as I start to rotate this, we can see we're getting an output here, and you can hear it varying the speed as it goes. As I move this back through, we can see that that changes. Now, Obviously, once we're sailing on this course, we may wish to alter course. So again, we can alter starboard, for example. And you can see 241, 242, 243. The ram's responding, and I need to close that error. And likewise, if I come back, 1, 2, 3, it's moving back in again, and I can close the error again. If I press button 3, I just exit whatever mode I'm in. So again, button 3, active, button 3, exited. That's program number 1. If I press this button here, button number 4, I scroll amongst the programs, so I can see the next program is program 2, next program is program 0, next program is program 1, next program is program 2. It defaults to program 1 if you just press button 3 and no other program is selected. We've also got here the functionality to adjust the gain and to tack to port, adjust the light backlighting, and adjust the starboard. So I'll just show you how that works. So gain, we just press button 5 once, and we see here gain is 12, gain is 14, gain is 16, gain is 18, gain is 20, and then it cycles back down to 2. My default at the moment is 10. Now, because I haven't brought this out on a boat yet, I'm going to obviously have to sort that out and maybe juggle it about a bit once I'm on board. Brightness, if I just do the same thing, it just cycles. So as I press it more and more, it gets brighter and brighter and brighter and brighter until it reaches maximum brightness and then cycles back to dark again. The tacking functions are similar. You just hold down these buttons or these buttons and it'll do a 100-degree tack to port or starboard. That is the main guts of it. We also have here action and alarm buttons. So you'll notice if I press a button, the red light briefly comes on. We've also got a buzzer, but I've got it silenced at the moment. So that comes on when you've either completed an action or the system's got something to tell you. The warning button, if we're in an active program mode, the active mode button comes on. If that then starts to have a warning, for example, the heading error is too big, you'll see that warning starts to flash and it's saying warning heading here. If I continue that round, I'm now getting an alarm. Now an alarm is worse than a warning. You'll see that it's actually dropped out of its program mode to mode 0 due to that alarm. So the warning, it will stay in the mode that it was in and it will just let you know with a flashing green light. An alarm, it will actually drop out of that mode altogether and give up. So things that cause a warning are a heading error and a moderate current. Things that will cause an alarm, basically there's only 2. There is a very large heading error or a large current. Actually, I've also got a low voltage as well. So those three things will cause it to go into alarm mode and drop out of program. Now there's various inhibiting flags in there as well that stop that happening. For example, if you tack, it would immediately drop out on alarm if it didn't inhibit that mode until the end of the tacking sequence. So it has stuff like that in it as well. I've obviously got a lot to learn on this. I don't really feel 100% confident making a video in here in the lab when I haven't C-tested it, but realistically I'm not going to be able to C-test it for another couple of months, and I figured that if anybody's out there doing the same thing that I'm doing with the intention of using it this sailing season, then it might be useful. There's a number of very frustrating lessons I've already learned doing this. So the first lesson that I learned was that the relays in this control unit interfere with the compass unit if the compass is any closer than about 70-80 millimeters. So every time a relay flicks, that compass is getting distorted. That was giving me all sorts of problems in the first place. There were many ways I tried to solve this, okay? So the first thing I tried to do was actually just move the compass further away. That worked, but then it was outside the enclosure. So then I thought, okay, I'll put it in the RAM itself. That's why I originally got that 7-core cable. Now, what happened then was the pulse width modulated current going through the same proximity to cables to the ITC line that was leading to the compass, which was now in the RAM, led to interference, which was screwing the whole thing up. So then I was back to square one, and I put it back in the box again, and because there wasn't much room in that box, it was then quite close to the motor driver unit, so I was getting induction off the motor driver unit. And so then what I did, which finally worked, was I actually moved the motor driver unit from here to here, which is a slightly more elegant solution anyway, because it means that I don't have high sort of inductive loads going down the main cable to this. It's actually handled locally. That seems to have solved it, so the compass is in that box unit, and that box unit is just going to be velcroed into a specific place on deck anyway. That's how it's going to go. So the other problem that I was having, and this was in many ways the most frustrating one because it took me a while to figure out what was going on, although of course it's always really easy in hindsight, is that when I put everything back in the box and I started testing the system, and I found that the Arduino kept shutting off and rebooting almost randomly. Not a problem I'd had before when I was testing it outside the box. So I immediately went down a rabbit hole of assuming that the only thing I've changed is moving it from outside the box to inside the box. Therefore, it must be some sort of interference, inductive interference between power lines, etc. Of course, it wasn't. What it actually was the rubbishy power supply that I was using only ran to a certain number of amps. So when the RAM was moving, it was occasionally dropping the voltage below the level at which the Arduino operates. The reason that had not happened before I put it in the box was because I'd almost always had it still connected to the USB in the laptop while I was testing it, and therefore the Arduino was being powered via the USB, which of course wasn't dropping. You'll notice today I did leave the USB power in during this demonstration. Now, this doesn't happen on the boat because it's got a big, powerful 12-volt battery supply, not this puny little 12-volt unit that I've got here. And that's why that was happening. The other thing that I forgot to mention was that there's also a HC05 Bluetooth unit in here. It's going to allow me to connect this to both my smartphone and my Raspberry Pi, and that's going to allow me to do a wind hold and a couple of other improvements. However, I suspect that might be work in progress that gets done during the course of the summer rather than something I'm going to get solved in the next couple of weeks. If you've got any questions, please feel free to comment in the description below, and also have a look through the Dropbox links as well, where I'll upload any of the code and any other useful stuff that I find. Okay, thank you very much.